Hello listeners, welcome to this third episode. The fluid flow is our topic, and our aim today is to derive the equation of continuity. Now, to start with, I have to define volume flux. Volume flux is the volume of a fluid passing through a given section of a tube or flow per unit time. It is also known as flow rate. So flow rate is volume flux. Now volume flux is flow rate. The SI unit of volume flux is cubic meter per second. Volume over fluid divided by time will give you what? Volume flux. So before I derive this formula, there is one important point that I need you to understand. That the tube of flow is not uniform always. But no matter which section of the tube you take, the volume flux in that point or in that section will always be the same. No matter which point you take, volume flux is always maintained. What I mean by that is that if you take a section of a tube and you calculate its volume flux, and you go to another section of a tube and you calculate its volume flux, you'll find that they are always equal. So having said that, I can say volume flux in section A is equal to volume flux in section B. Do you know how we calculate volume? Volume is calculated as cross-sectional area times height. So volume flux is cross-sectional area times height over time. Volume flux in section 1 can be calculated as A1 H1 over T1, while volume flux in section 2 can be calculated as A2 H2 over T2. Remember, from maths, height divided by time will give you velocity. So this formula now can be condensed into A1 V1 is equal to A2 V2. The product of cross-sectional area and velocity is a constant in a tube of flow. That is how to state the equation of continuity. However, there are three conditions that you must hold constant for you to state the equation of continuity. 1. The fluid must have a steady flow, the fluid must be incompressible, and the fluid must be non-viscous. So to put the equation of continuity in a better way, we say provided the fluid has a steady flow, incompressible, and non-viscous, then the product of cross-sectional area and velocity is a constant. A steady flow means that it is flowing without turbulence. Incompressible means that you cannot easily compress it. Non-viscous means that there is no friction between the layers of the fluid. Now, you can also be asked to define mass flux and derive the equation of continuity from it. Mass flux is the mass of a fluid passing through a given section of the tube per unit time. I want you to follow the steps that I've taken to derive equation of continuity from mass flux. You'll only realize that the only thing that has been added there is density. But you already know that mass flux is equal to volume flux times density. So since you have the same liquid flowing from section A and section B, we can drop the density. Now, A times V, which we call flow rate, is the volume flux. So volume flux times density will give you mass flux. Flow rate times density will give you mass flux. Thank you. That marks the end of our topic today. Remember to subscribe. Remember to refer your friends to this channel. Cheers.